everyone. I hope you are back and having a great one today. So let's get back into our simple Docker thing. Just going to tweet letting know that we are live. And we're live again. So trying to find, yep, avatar. If you can let me know if the sound is well, all of that. Hey Nuno. Hey bro, how are you? And we're live now, joining. Is the sound okay? Cool, cool. Is the music too loud? Can you give me your opinion, please? I hope it's good. Oh, thank you, thank you. So we're good to go. So, Simple Docker, our third episode. And as always, we'll do a quick recap. And then we will... You don't hear any music, so... What about now? Maybe thank you for the check. So... I think you should listen to music now. Still no music? Let me check. One, two, sound. Is it good now? Okay, cool. Hopefully not over my voice. One, two, sound. Yeah, cool. Thank you so much, bro. So let's get back into the plan for today. At least the starting plan. Maybe things can go differently. So let's make a quick recap and let's check how we can use this tool Docker Compose to manage multiple environments. So yeah, we've seen in the last topics of the live streams that we could store in a Docker Compose file all the information to this container, mapping ports to the outside world, right, to the host machine, or from the host into the container, more semantically. We can also define volumes that are folders in our machine. We can map them to inside the container, or also native Docker volumes that are referenced just from a name, and we can also conveniently store them or map them to inside the container so that we can reuse it across other containers or after removing and restarting a given container. So we left from here And let me just open a new terminal. And there we go. So let's jump into our, whoops, simple, no, not simple. Now it's simple Docker. And now we can see there is nothing running in our system. And let's inspect this docker compose.yaml file, and we can see that we are declaring a volume that has this name, and it's external to the compose, so the docker compose will not create it or remove it from its normal workflow, just knows and allows that we use it throughout the file. Oh no bro, thank you so much. I should. So guys, sorry, stream is starting right now. So thank you, Nuno. Right, even a quicker recap, we can see that we have a container that has a very basic Node application running, right, serving in port 3000, and we've seen that inside our Docker Compose we can store configurations like what image to run with the Compose utility, how to build such image, also how to publish a port from the container. So we're mapping 80 from the host to 3000 of the container. So any requests coming to the 80 port will go inside to such container on 3000. Also, we are declaring two volumes. One is a path on the host machine that goes to a path on the container. So this would be one folder inside our host that would be mapped inside the container. And also a named volume mapped to a path on the container. So this would be a Docker native volume that would be mapped to inside the container. So let's see this happening in real time, or I mean put our hands into it. Maybe we'll do it like this. So all I have to do is to run docker compose. I don't need to reference where the file is because I'm using the standard definition. So I just have to run up, and this will bring up all these services, and I will see the output. If I want it to run in the background, I'll have to detach it with minus or -d, right? So I'll just use it like this, and we will be seeing that the app is lift up. We'll check that by going to localhost. Whoops, so this is a search. Okay, here we go. And sure enough, we have a request that has been served with a response that we gave in port 3000, and then we entered on the container by the 80 port, right? What's more, we have mapped files and folders to inside. So let's recap how to go inside, and something more I want to show you. So let's go inside this container. So let's run docker compose exec in my service called, if I don't know what services are running, I can run docker compose ps, and service is web app. So docker compose exec. In the web app service, I want to run bash, right? So right now I am root user inside the container. And now let's just check again. Like in this folder, I have these two folders that are volumes. So slash storage, we have two mounted volumes, and in the other one, more files is the other content. So this is these are mapped files that now live inside our fresh container. And the thing I wanted to show you is that previously we had another service running. So I think I was mounting like a second service duplicated, right? I just cannot use same port, so I would have to do 81. So if I were to bring this up again, we would have two containers, right? One in port 80, another in 81. And if you notice, everything went, the warning disappeared. But right now, if I am to delete this, I will be warned that there is an orphan container, is because there's this container belongs to the configuration of the compose, but it's not referenced anymore in the file. So if we are sure we are not destroying anything that we need, we will lift the command with remove orphans, and this will make it disappear because it will delete any non-referenced containers that still exist in the compose project. So yeah, this is a quick recap for people that didn't see last episode. And we have Cavaco with us. Hello. Hello, João. How are you? Hope to find you well. Glad you could join. Sorry. So, coming back. Yeah, let's check how can we leverage Docker Compose to have multiple environments, because we will need those, right? We will be running Docker in local development and also in the production. Hey, Francisco has arrived. And I saw you later after I quit the stream, after I turned ending the stream, I see you coming in. Francisco, hope to find you well also. Welcome. So, coming back, let's see that what can we do with Docker Compose, what kinds of flexibility we might use. So, as a starters, I will introduce the file. We can make one file that is going to be called docker compose.override.yaml, and this means that we will be able to do stuff with this. And what kind of stuff? By default. Oh, so João is on the train going home and he will eat these videos after. So yeah, and let me know if you need anything else covered, if you are enjoying. Thank you, João. So override will do, it's a convention from Docker, and what it will do is that Composer will merge these two files if they exist, right? If we are not explicit, if we just say if we just run docker compose config, for example, let me close this one, up the font a little bit. So yeah, this is our the configuration that compose will apply when issuing commands. So, and we were not explicit about anything. We were using conventions. And what conventions are those? We are using, saying to compose that we want to use docker compose.yaml file, and also after that we will, okay, let me show you. In the first instance we run this and we get exactly the same. Let me show you now. Second one is, it doesn't exist, but when it exists and we are not explicit, it will also merge override.yaml file, and first it loads the first file, right? And the second one, it will merge and override any collisions. So what can we do? We can say, for instance, that there's a service, it's called web app, for any reason. This is just for demonstration. I want to say I could use another image, right? So if I were to issue the command again, we'll see that web app now is using another image as the image for the container, right? So of course this might not be the most useful, but who knows, we will use another port we are overriding, and I don't know, let's say 8000, just for the sakes of looking at this. So now we see that we even have a merge, right? Because it's an array, so it's not a collision, so it's merging, because well, now we have 3000 from the 80 from the host, right? This one, and we also have, so this one and that one. So now we have two mappings from two files, right? Okay, so this is not it's an array, so it's not overriding, but I guess if we were to use 80, I want to map it to 88888, for instance, just for the learning. We'll see that we are targeting 8888 to the 80 port also, so I'm not sure how this would work. So what would this make? So let me just try. Never tried anything so gnarly like this. Okay, so not this. Yeah, I want to use this command. Oh, right, and it makes totally sense. What we are doing is to try to assign another service to one that already exists, so it just fails, right? That makes total sense. So there are stuff we might want to override. So this is why Docker Compose uses exactly this. So I will give you a sensible default how to use this, and we are going to ignore this file in the Git repository, meaning that it won't be sent into the repository, right? So it didn't detect the new file. And what happens is, when we clone this repo, we can just make this file and overwrite anything to this file. For instance, there is a MySQL container that to be working in the Apple Silicon chips, they need a different version. So maybe you are using a version, a repository that has another version, not Apple Silicon compatible. So that would be an example of what you can use the override for. So yeah. So having seen that we are using that override, let's see something else. If we are being explicit, so we are not saying to use the override, right? It's most likely, I'm not sure, but we're here to find out. So we would say another one, right? So if we are explicit, it will not override, right? Because you are being explicit. I want to use this file or this file and that file. So it wouldn't make sense to use the override. It will just use the override if you, for example, are not explicit. So yeah, there we go. Okay, so this is it for the override, and I want to mark this. So using override, and what we're going to see now is something that we could do to do a different development and production image. For example, we might have Docker Compose and Docker Compose .prod.yaml, right? And in production it would be one file, in local development would be another one. So we would, so let's say this is not going to be true, right? But let's say we are going to map, or it doesn't have any volumes in production, and it's 3000 to 3000. So easily you can predict that in production we will use the file prod and up or config, and sure enough we have our configuration as set in the production. So yeah, this is something we will see right now how to use with this simple application. Let's put our hands onto it. So using dev and prod compose files, right? So maybe we could find a next application or a JavaScript simple application. Let me try to find in a second. Let me know, guys, if you have any question you want to see covered. So coming in the other screen to find the repo where I can easily find. So this is a next application. Yeah, I guess we can do just that and have a next application working, or Okay, let's start with like we are, because I'm afraid that I will bring too much into the table at the same time. So what we're going to do is that we are going to have a different setup for our application locally, and we will build it and ship it to a production server, or at least pretend it. Okay, cool. About this node application, what we have to do is to monitor the thing, and I guess we can do that with PM too. And so, okay. Where is PM2? I'm trying to find in a repo, and I was so sure that it wasn't in this repo. Okay, so let's do that. We'll install PM2, start app.js. So what this will allow us to do, it will allow us to put some application to run in production, but also in environment to change sources. And I guess it will be good to use for both cases, both development and production. So, but what I'm afraid is if this will take me so much longer than it should. So I think there's like express up reload when code changes. And we can use something like nodemon. Yeah, here it is. So that easy, yeah? Okay. So let's do that. And let's run, let's put another script for dev. And we'll use nodemon. And before that, we need to npm install nodemon. I guess, was I using nodemon? No, sorry, I'm still getting used to another tool. Okay, so npm install nodemon using pnpm, so much faster. Okay, and I'm doing that in my machine. Of course, we could have done it inside Docker, and that's what we're going to do, because we could have, after we built, we could just go inside, yeah, because we're using node. So what we can do is, let's check if is anything running. No, it's not. So for instance, we could just docker compose, and we could run a one-off command, right? So Docker, I have this alias, right? Instead of Docker compose, if I just write DC, then you know what it is, right? Sometimes I might forget. So Docker compose, run, and I want to remove the container in the end. So --, rm, just like in Docker command. And inside the web app service, right? Yeah, inside the web app service, I want to run bash, I mean. Whoa. Docker compose, simple docker. Okay, what did it do? I was expecting for the image to be built already, but maybe I deleted it or something. Okay, no problem. I'm inside that container, and the outside directory is right here because we mapped it, right? Nope, we didn't map it. So this is not in real time. What's happening here, be careful. What's happening here is that when we did the Docker file, we copied everything to the root, so to the working directory. So some file I would change here. So for instance, index.js. Let's say here it's 3000. So if I were to change something just to fail, if I see there's no difference, right? What we have to do, Docker compose wise, I will just quit this and stop mapping these volumes. What I'll do is just to do a volume from the current working directory. I want to map it to inside app folder. So sure enough, yeah, if I am to run again and I do cat index.js, so now I see the real output, not the real folder, I mean, because even though the files might already exist here, when we mapped the outside folder to inside, we overrode it, right? Cool. So in our index.js file, we are inside the container. So let me check if we have pnpm. We don't. So we can install that. Install pnpm. I think we installed that just right with npm. Exactly, we can do that. So I will prepare this image a little bit differently now. Maybe use this for a reference later to have it as to use again. So I want to run npm install pnpm. So, and this is what I want to use. So I want to use pnpm. That's it. And I want to have it ready to use. So I'm going to run docker compose down to remove all containers. I'm gonna docker compose build, and right now this was not in cache, so we see it again getting installed. Cool. If I was to run docker compose up again, we could, if I hadn't done docker compose down, I could accidentally not have the latest version of the image. So what we would have to do was to force the build like this. So this way it would just force it, right? It was a simpler, more direct way of using it. Bring it up, but build it first. So it's building right now, right? it's built and running. So I'm going to issue that command again, just as if I still didn't have installed nodemon, and I'm going to do it inside. So I'm going to run the command in the newly fresh container, and we have npm, and now we also have pnpm, right? So with pnpm I could install nodemon. pnpm. What happened? pnpm now wants to use the store at pnpm store. So, oh right, I installed from my computer first. So what I'm going to do is to remove node modules, because I installed in the different this folder came from a different system. So what I want to do is like pnpm install, and from now on I will use only the container, so it doesn't matter what I have in my operating system, or if I have npm or node installed at all. I don't need node if I'm doing like this. So I'm running inside the container, so I could do pnpm run dev. So now this is to work, right? So to restart at any time, enter rs. That's cool. I will click rs, and it reloaded all the code, and it's watching these paths. So hopefully enough, if we were to change something in our code, we would see it restart. Let's do that. So let's say hello simple docker reload when change, and I'm going to save the change. I did, and we saw that now the code forced the restart. So we can come back to localhost. Okay, we have to check what's going on. Okay, yes, and no ports mapped. Oh right, because I ran it out of the one-off command. I didn't run up, right? So I did my one command, so it was not mapping ports. But now I'm gonna docker compose up, and this started the entry point. So this development, I wanted to start developing, right? So docker compose.yaml will have to run pnpm run dev. So that's what we're going to do. Dockerfile is running npm start, but we'll make something else. We will say in the development compose, it's where we are, we will run different command. We'll run npm pnpm run dev. So docker compose up, and now we see it has nodemon because we changed the command to run, right? So if I am to change reload when change, reload, yeah, whatever, command S, and you see it changed. It was docker inside the container that saw this. So I am to refresh, and I am to see the changes in our code. So let's do something. Reload when something happens, right? I saved it, and now refresh. and it was down and then up again. That's why it failed, because it was restarting. So yeah, we are now in development able to change the stuff, the source code, right? And what we got. But this is not what we want in production, right? So in production, we will want a built image, right? We will not run a development command, and we will not be listening for changes. So our Docker file is using start, that uses the default node, not listening for changes. And this is where we could put PM2, making sure that everything would start if there's an exception thrown and the process stops. So PM2 will allow us to have multiple processes serving. So it's a tool to take seriously when we're deploying to production node applications. And what we're going to do is to simulate both environments, right? So dot production is different from that one. What we're going to do is, let's say in development we can no, I don't want to make it more complicated than it is already. Let's keep it simple, right? So quick recap. Docker Compose for development will not use any volume for now. It will use one service, its web application. The image that we'll use, it's this one, and it's going to get built from the current directory context with this Docker file. Because Docker file has a default command and not an entry point, we'll see that later. We can override, so despite this being used, despite this being declared, we're gonna override it, and this service will run pnpm run dev, which in turn will run nodemon index. Ports, we're mapping 80 to 3000, and volumes, we are mapping the current directory into app. So what we're gonna do next is, let's even open them side by side, shall we? And we will fix this and run pnpm start. I think this is feasible to do. Doesn't need the run keyword when it's start. When we'll be building, we will not have, we see in Docker ignore, we don't have node modules copied to the context. When we do this copy, we don't have the files in Docker ignore, so we don't have node modules, but we do have pnpm lock is from this file that pnpm will install the dependencies here, right? And then the command is pnpm start in production, because we will not use it in production. Quick recap. We'll just use one service with the same image. If we need to build it, we'll build it like this. We also don't need a volume. And we are going to map 80 to 3000. Notice that we're not mapping anymore. We could map different port. In production, most likely we will have a reverse proxy running the website for SSL, the web server in front. So most likely we can run it 3000 just for the sake of being different. We are not going to issue any command, and that's it. So yeah, let's pretend we're going to launch into production and run by running this. So how can we do that? We just have to issue the command docker compose -f docker compose .prod YAML and up. So we are listening on 3000 in the container. No nodemon started, right? Nodemon did not start. And if I were to inspect docker ps, we can easily see that we have 3000 mapped into 3000 listening on any port. So if we were to go to localhost, we don't have any answer. But if we go to the 3000 port, we see that we have it running. What's missing? Just a simple thing that we could have done. But of course this is not final. But know that if a container breaks or stops, we can have it restarted. No, not if the container breaks, that's different. But for example, if the VPS reboots and starts services again, Docker will bring this service to a restart again. Okay, cool. I will stop that. And now I will use the default Docker. And we'll see the differences. So if I was to do docker compose up, we now have nodemon, right? Because we're using the different. Now we're using this file. So we're using another command and even mapping another port, right? So here we are mapping 3000 to 3000 and before, and now we are mapping 80, and look, even 8000 is being mapped. And why? Because we left that file docker compose override dangling here, right? So that's why. And it built, if you're thinking how was it able to run another one, is because he built that image one from the other. If you remember before, we have seen that in the previous episode. I invite you to go back if you didn't see. We can make images from other images, and we can tag them, and Docker is clever enough to have a cache in place. So if you have one image and you want to make a second image that is just a different name, it's just a matter of a second or less. So that's why we didn't see it happen. So yeah, sure enough, we do have a development environment running. We can go and change code. So hello simple docker. So I don't know. Now is dev time. Whoop. And I saved, refreshed, right? So I will not get an answer here because development is running in 80. And sure enough, now we have it running. So yeah, this was a brief introduction to Docker Compose files. And I think we have 10 minutes more. So we can close this up. Does anyone have any question? Now is the time. Okay, so let's remove this console log because we don't need it. Okay, I could start thinking to delete these files, and I should. We'll stop using that volume. If you want to go back to a different version, we can check for different episodes. They are available for you to to reach, I will put you in the chat. There you go. So you can visit like it was before and just practice anything you want. So nope, not here. Let's go back to the code. Quick revision. Docker compose prod, compose. Very, very simple. We have compose files. That's it. Maybe, of course, we don't have it right now, and I'm not used to use this bare node, but let's try to see if we can easily find a service. What could we have it running? Yeah, I think it will be for a different one, and we'll do that later. So Docker MySQL, for example, if you want to have a running instance of MySQL or Postgres or whatever your taste, let's use, for example, this is a good use case. We'll add these two services even with an adminer, so I'll copy that and let's use these in the development, right? So we'll use this. It's not well idented, now it is. Okay. So if this is not recommended, why is it using? I'm not sure, but I'll leave it there. It's just for development, so don't copy this for production. And we changed development compose and see how easy it was. We'll add a service running MySQL just for this project that will be up when we run this compose, and it will stop when it's outside. Let's check the volumes, how they recap here in the database. And also we have adminer running. Do we have that restart? We don't need it. Not sure why it's there for the development. So also we will have adminer import 8080, and also we could publish MySQL port to the same as the default, right? So I want to put it in codes, and that's it. Let's go back into our website shell. Let's bring up the website, and along with it, it is pulling already more images. As we can see, the output is a little bit crazy because of the font size, but all is good. We have DB running, web app running, and adminer running. There it is. So you might be wondering, and for sure, in localhost 8080 we should have by now, an instance of this web interface to manage a database. So the server is going to be DB. Why is that? Because the container, so I lost the connection to the iPad that I used to use the pencil, right? Why isn't? Wow, so this is not good. So just sorry for a second. And what's happening? Yeah, I should get a cable connection for the sidecar for this. Yeah, so this is a bummer. So the show must go on, yeah. So I will just change resolution again, bring it back, bring it back. So here we go. I don't have the iPad anymore, but that's not a problem. We'll do it like this. What happened now is we added few services, right? MySQL and adminer and so on. So adminer, MySQL, and where is the web application? I don't see it. So it stopped. Oh, right, because it crashed and it stopped, right? So what's it trying to do? It's trying to run up pnpm model not found. So because maybe it's running different command, different container. I don't remember now. So let's remove all containers by running down, and let's bring it up again. Now I brought it up in the below screen, no problem. So let's change this to up. Oh, and just one, right? So now it's the Murphy law in place. pnpm run dev, and the image is the same. So when I built it for production, is the same as building here. So Docker compose up. Let me build it again. Don't remember if everything went okay. Now we have pnpm, and yeah, we now have the web app running. So adminer, db, and web application. So that was that. So regarding our architecture, it changed a little bit. So what happens now is that we have our host machine. Okay, so this is not so good in with the mouse experience, right? I should go to a diagram application, and I have it, but just to be quick, we also now have a container running db and another container running adminer, right? So don't mind the font. And adminer is running in 80, right? db in 33. Whoop. What kind of 3 was that? So yeah. And what kind of 6 is that? So, okay. And outside, we also mapped into these ports. So copy and paste, right? I think it will be quicker. So docker ps, we have 80, 3000, and the other ones are the same. So we'll do this, copy. If we get a little bit of luck, it's almost there, yeah. And also paste, because now we will use those 3, right? And for a network, we do have, I don't know, another color. And this 3000 is running in 80, 3306 is right there, and this 8080 is using, jumping that one. So that's why I'm able to enter. If I go to the host machine, I am entering 8080, right? And it will go to inside to adminer, right? So this container has to reach a database, and it will do it by going to the host machine in this port, or of course there's the Docker network being used in place. Let me delete this, just not to be there. And adminer container can just go directly to this port, and the host that DB is using, we could declare it for a DNS entry, but for the host name to make the network entry. And if we don't, Docker will be kind enough to use the service name, so DB will do just fine. Adminer will be able to reach by DB in this port. So what's the password? Example. So yeah, let's do that. DB root password, so we can put root example and no database, and we could enter. So yeah, we are visiting our database, MySQL, just freshly installed, and we have a UI to check records, for instance. So yeah, this is how easy Docker Compose can turn this kind of stuff. And of course, this just happens in localhost, in the development environment, because in production it will not have that services. So you see, now we can do different stuff. About volumes, let me show you something to finish. So let's make a new database. I don't know where it is. Oh, it found in Portuguese, probably from the system preferences somehow. I don't know how. So let's create database and make it a simple Docker database, which might have a table users. Table users, which have an ID. So it's an integer, auto increment, and yeah, that's it. What can I do here? Oh, add next. Okay. Save, and we have one table called users. So select data, no rows, new item. Okay, so I didn't put a name. Okay, users, alter table, add a field, name, varchar 255, whatever, save. Okay, so now we're going to do a new item, and it's going to be Patricio as a first user, and sure enough we can select data, and there is one record inserted. So what we should do, if we don't want it to be destroyed, when we do docker compose down or docker rm command, is we should map a volume just like this one, for instance, and that's what we're going to do. So MySQL is using MySQL latest, right? And I'm going to find from another project where's the path for the MySQL data, because if we were to, I think you will believe me, right? But now I have to do it, right? Because if I will do, I just stopped the container, right? This is not working anymore. If if I am bringing it up again, even if I build, MySQL is not built, right? It's brought from outside. If I were to visit again, I have the session back, right? And the data is still there. If I select data, it's still there. But if I were to Docker compose down, so you see now it removed containers, and because it didn't have any volume mounted, all our data went away. So what we're going to do is to use the volumes, and let's say MySQL database, and this will map to somewhere, okay? But first I need to say that hello compose, please make a volume called MySQL DB, and you manage it, you create it, and you remove it, right? Okay. So this image has to be mapped, this volume has to be mapped into this folder. So this is where MySQL stores data for the database, and next time we bring it up, it will now bring it up here. So let's run, we ran Docker compose down, and now we're going to run Docker compose up. So it's creating everything all over again. And if we were to go to refresh, we don't have any session anymore because session data was in the other container we just destroyed. So let's fill these again, root, example, and it found this from some data. And what data was that? How was it able to get it? I'm not sure. Probably it was in local storage or someplace, I'm not sure. Okay, but I don't want to select any database, it's whatever, I can choose it, even it does not exist, right? So you see now it doesn't exist because we removed it. But right now we can create it again. Let's call it something else, or not. Simple Docker 2, let's say. So let's create again users table with an ID, auto increment, and a username. Okay, let's create this table. Let's put a new item. Let's save it. We have data, right? So now if I were to stop this container, Docker compose down, you see container database was removed. Okay, service is not running anymore. I will bring it up again, and of course the container for adminer was deleted, so I have to start this again. It reminded that it was in this database because we were using it, so I think it's going to be local storage. So you see database is still here, and table users also, and our data also. So this was a quick recap, revision to the volume thing, but what we've did is we asked Docker to declare one more volume, right? It was called MySQL database, right? And map it to this container into that path, right? It's what happened here. So next time I deleted the container and brought it back up and mounted again this folder into the storage directory default that MySQL uses. Sure enough, we still add the data. So yeah, this sums everything up. We are 1 hour and 10. We are after the time. So I'm not sure. So episode 3, I'm gonna close it like this. And whoa, I did not git ignored this folder, so I'm into troubles now. So git rm -r cached .pnpm store. Okay, always make a mess. It's okay. So git status deleted, and we're gonna git ignore this store also. So yeah, removing everything, and again episode 3, git tag episode 3, and git push with tags. So yeah, if you want to check out and play with this setup, make your own volumes and your own experiences, have it tested with your hands on. That's always a great way to learn, at least with me, and I hope you will enjoy it. So any questions, anyone? So this is really the time. I'll be closing. And of course, I will try to keep this consistency, resume it in a blog post format, the indices for everything. I still didn't do it, but I'm really trying to push for 1 episode a day, and with a good indices, I think it can be a good reference, and you can come back and see everything in detail happening real time. Okay guys, so thank you once again for everyone that came up, watched live, watched after recording. I hope I see you in the next one. So happy coding. Thank you. Ciao.